Okay, so in part one, we georeferenced a vintage topographic quad, giving it geographic life so it knows where to live, and especially so we can now line up true elevation data to that vintage map so we can start popping it up. So we need to now find some elevation data, clip it, and let's just do that. Okay, the first order of business will be drawing two polygons. One polygon around the outside of this paper edge, and then the second polygon will be the neat line of the map itself, including this sweet little jog here. Now, there's a super convenient way of doing this. You can just insert a map note. Honestly, I just learned about map notes, the ability to quickly draw a polygon with a map note from colleague Warren Davison. Thank you so much, Warren. This is going to be such a time saver. So I've inserted polygon map note, and now I'm going to go into this edit tab. I'm going to create polygon. This is my destination. I'm going to create a rectangle, and I'll just define the corners and draw it, and I'll hit save. Checking which one I'm actually saving. Yes, that one. And I'll rename this paper. Now I'm going to do that again. I'm going to insert a different layer, and we're going to call this neat line. And now inside neat line, I'm going to draw a polygon, more complex polygon, and I'm just going to trace the edges. Turn the paper off for a moment. And I'll save that. Yes. And I'll clear that selection just so it's not always glowing blue. Get rid of that. And now I have two rectangle layers, or two polygon layers, one for the neat line and one for the edge of the paper itself. Now it's time to actually get the elevation data itself, a DEM. Let's center my map a bit, and I'll right click my map and choose Add Data, and I'll hit my favorite tab, which is Living Atlas, and I'll search for terrain. And I've got a terrain image service here. It covers the entire world in remarkable resolution. Check it out. Now I'm going to extract a portion of this elevation model that covers my paper. So I'll turn on this paper reference and I'll choose terrain, right click, data, export raster. By the way, another thing I didn't know I could do till Warren told me about that. Thanks again, Warren. I'll choose a destination, name my new image file. The clipping geometry is interesting. I'm going to set this to the extent of my paper layer. My output format, I would prefer to be a GeoTIFF, and check out this raster size. The limit of this service is 5,000 by 5,000 pixels. So I'm going to get everything I can and steal only 4,999 pixels by 4,999 pixels and save this to my machine. Alright, there it is. Let's turn off the image service and see what we're left with. Alright, a digital elevation model covering only our area of the map. Isn't that great? Now you could also use your own local digital elevation model or a NASA SRTM, but you can use whatever you want. Now that we have an elevation model that covers the extent of the paper, our next step is to clip that elevation model to only the extents of the map itself within the neat line, including this cute little jog. And we'll do that using the Clip Raster tool. The input will be our clipped DEM. The output extent will be the neat line that we drew. And it's important to use these features for the clipping geometry, or else it'll just take the rectangular extent instead of the true extent of this vector. I'll define a location and run it. Okay, now we've got two DEMs, one for the paper, one for the map itself. One of the defining characteristics of this style of a bumpified vintage topo map is the fact that the hillshade on the map spills over into the margins of the print, which is really cool and makes it look like it's boosting up off of its paper environment. Now, how do you do something like that? Because the hillshade needs a place to spill over into, and right now the hillshade input that I'm going to be using is clipped perfectly to the map. What we need to do is calculate some dead zone pixels for this image, and we'll do that using the raster calculator. Now this is a formula that Warren Davison came up with. Warren pretty much was my co-conspirator for this section of the project, and it goes like this. Condition is null, so make everything in my input that is null for DEM map. Give it a value of 268. 268 happens to be the base value, the lowest value within my map area. DEM, this is the input again, map. We'll close that out. So if this value is null, give it a new value of 268, my lowest elevation. Now the trick is, over in the environments area, we have to set the extent to be the same as our paper. I could use the topo quad or the elevation. I'll use the topo quad, isolate the variables, go back to the source. So topo quad is going to look at the extent of topo quad and fill in all of this area with a baseline elevation of 286. And I'll name it. There we go. It's ready to have some hillshade applied to it. Okay, that does it for part 2. The DEM stealing, cutting, and hacking to get our elevation data all ready to go so we can apply some hill shading to it in part 3. See you there.